In this video, I will provide a brief introduction to the Ahnung automated machine learning pipeline. So what is Ahnung? Well, the name comes from a word in German meaning having an idea or understanding of some topic. The Python repo named Ahnung accelerates machine learning workflows for categorization and regression tasks. This is accomplished by combining a schema analysis with the AutoSKLearn pipeline and a Flask web application. The web interface displays performance results of the machine learning process and provides a REST interface implementing the selected task. Early versions of Ahnung only support categorization. Support for regression tasks will be added in the future. Ahnung uses a MongoDB collection as a source dataset and also stores metadata and the ensemble of machine learning models in a MongoDB database. The Ahnung pipeline has 4 somewhat independent stages: schema, cleanup, model, and predict. Each stage depends on the output from previous stages. However, you can adjust settings and restart a stage without rerunning the earlier ones. When Ahnung enters the final predict stage, it provides one or more URLs for accessing the Flask web interface. This interface provides resources including a REST URL, implementing the categorization or regression task, and several visualizations of the learning results and ensemble of machine learning models. The first section of the web interface provides a bar chart showing various performance measures for each label and the categorization task. In this case, there are 2 labels, less than or equal to 50K income and greater than 50K of income. The next section provides statistics from the AutoSKLearn construction of the ensemble of models. The third section lists the URL-based resources available. The prediction URL implements the categorization task. A sample curl command is provided to illustrate the expected input. The pipeline profiler displays a visualization of the various components and models present in the final ensemble. These are sorted by the internal cross-validation accuracy of each model. The confusion matrix chart shows the predicted label fraction for each of the true labels in a test against held out data. In this case, we can see that the less than or equal to 50K label was predicted correctly 87% of the time and incorrectly 13% of the time. The ROC, or receiver operating characteristic charts, show the true positive rate against the false positive rate as the decision threshold varies for each of the labels. Since this is a binary classification task, these charts are symmetric. The feature importance via permutation chart indicates the relative importance for each attribute in the current ensemble. So if you run Ahnung multiple times, the precise ordering of the features can sometimes vary. However, in most cases, the features tend to stay in the general area of the list when sorted by their importance. The final 2 sections list the attributes of the input dataset that were selected for use in the ensemble and any attributes that were insufficient to be selected. So for each of the selected attributes, we can see the type that was found and whether they were interpreted as numerical or categorical attributes. For the unselected attributes, we can see how often they were present, how many distinct values they had, the types that were found, and the reason they were not selected. I hope this video has helped you understand the Ahnung automated machine learning tool and how it can help with your data science projects.